Hey guys, I believe I am live. What's up? My name is Wills. I run Williams CSharp and engineering walkthroughs. I'm just gonna double check, make sure I'm live. I had some issues with OBS just now earlier. I tried to go live and it wouldn't my OBS wouldn't cooperate with my YouTube studio. It was really strange. But it looks like I'm live. My thumbnail was off though. It's my old thumbnail. I'm gonna have to update my thumbnail. Yeah, that's cool. Calm. Okay, looks like I'm live. Hey guys. It's been a while. I've been on a bit of a hiatus, it seems, maybe. I did release a video this morning, UK time, that is. I think it was the morning/afternoon. It was actually the afternoon, it wasn't the morning. This is going to be a chill stream. As it's going to be a chill stream. I released a video this afternoon regarding some engineering stuff, control theory and engineering. This channel is kind of going through some changes for the good, but I'm still at the roots of .NET C# development. I still very much support C# in the sense of a developer. Yeah, man, I just realized my sketchboard is on the screen. And it's gonna be a really fun series. If you're familiar with my Parallax engine that I developed on a few live streams, I actually released Parallax Engine. I released Parallax Engine as a set of classes, as a Visual Studio project that developers can use to build 2D games on top of. I've realized that project. I made that project what I kind of set it out to be, in a sense. Did I have more plans with Parallax Engine? Yes. But this is where Vanguard Engine comes in now. So I realized some of the limitations, some of the constraints of Parallax Engine. And moreover, I realized that there are ways that Parallax can be better. Of course, if I implement my game framework, my game engine as a set of libraries, that is like the ultimate way to implement my game engine in a sense. But, excuse me, for the sake of simplicity, right now my engine, Parallax Engine, is implemented as a set of classes on top of Visual Studio. So you have to literally, you're not loading DLLs into Visual Studio, which is ideal. You're actually just loading a project file, and you're building on top of it. Vanguard Engine is still going to take that blueprint, but I want to go a step deeper. So I'm going to introduce this new series, Vanguard Engine, where I saw some of the constraints of Parallax Engine. For example, I'll give you a good example. So in my spare time, I tried to build a game scene, right? And it was possible. I could, on top of Parallax Engine, I was streaming in some textures, I could say, some sprite assets. I had the controller mechanisms up and running, and I could build scenes. But it was taking too long. Something didn't feel right. And then I realized there was too much in the way. There wasn't enough in the way of abstraction. Where I felt comfortable extending Parallax Engine. It was more like I was modifying the engine in a sense, which is what, when I'm building a set of classes where all the members are basically exposed, I'm kind of modifying the framework. But what I mean is that I didn't build Parallax Engine in a way that caters towards like abstracting the heavy lifting enough, I felt. And I want to address this with Vanguard. So there's a new series. At the very, very least, Vanguard is going to be a reboot of Parallax Engine series. I'm going to build a game framework from scratch. You're going to see that in this series. And I suppose I could say at best, or towards the best of the spectrum of what this series can become, is that I improve upon Parallax Engine, where I strike a balance, and I try to write this down. I strike a balance between abstractive layers of behaviors, constraints, functionalities, mechanics, abstractive layers, writing them and abstracting behaviors of a game engine, of a game's world, and the customizability of writing C# code. I want Vanguard to sit somewhere towards the middle of of the spectrum of writing raw C# code and sitting on top of an engine, somewhere in between. Excuse me. So the good news is that all you need to get started is Visual Studio. Visual Studio is free if you get the Community Edition. And before I get into the nuts and bolts of coding, before I begin coding, I'm going to go through some of, and this is another thing, I didn't really implement enough in the way of design patterns to really optimize my engine in Parallax. I want to address this with Vanguard. So I listed a few design patterns. We're going to go through kind of the theoretical stuff in this stream. And I think this stream might be quite short. It might be half an hour to an hour, where I'm just literally going through the concept of the framework. I may not code as much in this particular entry. This is episode 1, so take a second to you. But it's important. This is an important step where we kind of and I could go more in depth, and I should really model my framework using UML or something like that. But right now, I just defined some of the principles that I want to draw out on my toolkit, my OOP, my object-oriented programming toolkit, to help me build a framework. Because this is the thing. Before I started the stream, I sat down and I considered to myself regarding Vanguard, what makes using an engine like Vanguard, what makes using an engine like Vanguard an advantage, besides just writing an engine from scratch, writing a game framework from scratch. Let's say it's tic-tac-toe, right? And I want to write tic-tac-toe from scratch using C#. I've done that before. I have a video. It took about 2 hours, and take that long. Maybe some people could do quicker than me, but anyway, it took me about 2 hours live on stream to build tic-tac-toe on C#. It's somewhere in my archives. It's there somewhere on my YouTube. I think it was a live stream. I'm not sure. What's the difference between doing tic-tac-toe with raw C# and using something like Vanguard? And I think I came down to one of the main pain points of game development, and that's level design. How can levels be designed while taking out the majority of pain points that developers have to go through, or game designers have to go through, when designing a level? Because that's one thing with Parallax Engine. I know I'm talking a lot, but I think it's quite important I address this. When I tried to build a level in Parallax Engine, I had the drawing streaming logic all there, the draw update calls were all there, But when it came to designing levels, it was still really, really involved, to the point where I thought, wouldn't it just be better if my engine kind of facilitates a way to design levels intuitively? And that's what I want Vanguard to address, because that's why people use editors like Unity, right? Engines like Unity and Unreal and Godot offer an editor layer, a UI layer, such that developers can actually design levels with minimal code input, because of the abstractive layer of using a UI layer. How can I achieve that kind of utility, that robustness, but using a code IDE such as Visual Studio? That's what I want Vanguard to address. And that's what I decided will be one of the unique points about Vanguard Engine. I'm going to stretch my leg a little bit. Right. There's not a lot of space between my chair and the desk, so... So that out of the way, guys, my explanation about Vanguard and game engine stuff. We're still going to dive into game engine mechanics and stuff. I've already installed Win2D, just so I can kind of turn our attention to Visual Studio. So the main graphics driver, should I say, the main API we're relying on here, the libraries for the visuals for drawing, is Win2D, as you can see here. I have Win2D UWP installed. You can find that on NuGet. I shouldn't have clicked it. Yeah, because my laptop's really slow, guys. So I click one thing, I right click a space, and it just takes ages to load. So I'll try to be mindful. I've Win2D. We're gonna be building on top of that. So the question is, where do I even begin? Where do I start? I think to answer that question, the best way for me to kind of address this question, where do I start? For me personally, again, it's a chill stream. I'm just like talking out loud. Is what do I want to build as a developer, as a game developer or game designer? When I meet an engine, what's the first thing I want? I want some kind of simple scene, right? And we work backwards from that. That's how I've always kind of approached this question. So, in order to do that, I need to ask the question, as I just said, just to reiterate myself, what do I want to build? And it's probably going to be some kind of like a player agent and like a background or something to just kind of show I can an interaction mechanic to show that I can interact with a player agent and kind of like move through a world. Then I have like a very, very, very rudimentary world, right? A player agent, some form of world, some form of a biome, like a world biome, and a controller mechanic so I can control my player agent, right? So that's what we're going to reverse engineer, that concept of creating an interactive biome. And we're going to use some principles here to help with the engine itself. I'm not going to go through like line for line. I'm not going to like go through this comprehensively. Just using my notes here, but it's more like a reference. Right. So I suppose the question I would ask myself, oh, and I will use my sketchboard a little bit because it will help to kind of illustrate this before I get into the code, is before we even get into mechanics, how much of the heavy lifting do I want to do as a game developer if I use Vanguard? Because the idea is not just me, it's like other developers in a studio, say, this is a general example, will be using the same set of tools. So development is about collaboration. There's a lot to think about. Okay. So when we're developing, I don't know if I should make this full screen. Let me just have a look at my OBS here. Is it better full screen? I'll leave it split screen just in case I want to do a double duty. How much of the screen is that big? Nice and easy. Not a lot of space. If it's not a lot of space, I'll just go full screen. Sweetness. So, end result. I'm using mouse for the drawings. I don't have my Wacom like I have in the past. So do excuse some of my wonky drawings. Okay, so some game scene. Let's just say we have a player agent. Player agent, PA. We have our scene, right? And then we want some kind of control mechanic, so we can, traverse our biome. X, Y planes, right? That's the core idea of what we're trying to do here. So we're setting constraints, we're loading assets, and we're setting controls to govern these two. So how do we do that? First thing I want to go for is the assets to load, because I think if we have something to look at on the screen, it gives us a good starting point. So how do I do this? I'm gonna have a class. I'm gonna say AR, animated resources. You might be familiar with some of these terms from some of my other live streams. And this class, as the name suggests, will just load my animated resources, right? So I will, by invoking methods in this class, these are all pseudocodes right now, or just pseudo drawings. By invoking methods in this class, we should be able, in theory, to load resources onto our scene, right? So we can have a method. Let's see now. I don't want to just be talking out thin air, basically. Yeah, because we're sitting on Win2D for the graphics. So what I want to do, I'm working with these things called bitmap objects, or canvas bitmaps, better said, as you probably would have seen from if you watched any of my previous live streams. Canvas bitmap objects. And what these objects can do, we can basically use them as sprites. So when you construct this class, basically what you're doing essentially, you're taking, what you can do is load, you can stream in from your hard drive or your SSD or your asset data pertaining towards graphics. You can load that as canvas bitmaps, and as such you can run them at real, you can draw your assets at runtime, is what I'm trying to say. So we need a facility for that, and it's all going to be governed by classes with abstracted by methods that can access these lower level behaviors. This is where we start to touch on some of the design conventions that I may want to consider for this engine, because I could go for the monolithic approach, but I'm trying to avoid that where possible. I want this engine to be quite modular and extendable, maybe even modifiable as well, I'd say. Because I'm not particularly hiding the implementations here for this build of Vanguard. So it's, by definition, this engine, this build of Vanguard is modifiable. So it might as well be modular in nature, such that it's intuitive. Vanguard is intuitive to modify, although we shouldn't really be modifying our framework. We should be extending its functionality and feature set. So for the sake of the stream itself, I do want to just kind of get on with things. If we can get to the stage of showing something on the screen, that'd be great. But again, it's going to take a lot of thought. But let's try and make some progress here quickly. So I am going to use reference code from my Parallax engine, so you're going to see me going back and forth. I have code that I've written for Parallax engine. So let's go straight to our markup file, which is our XAML file. As first things first, we're going to need a canvas control. If we're and think about, so the way I'm approaching this, I'm looking through the lens of a UWP development environment. So I'm developing a UWP set of classes, Universal Windows Project set of classes to make UWP games. In this case, it's like they're 2D, right? So a lot of the constraints that I will meet here are constrained to the UWP environment. So if that's not what you're interested in, you might not want to watch this tutorial. But if you're interested in making like UWP games, which, as far as I'm aware, most games and apps on Windows platform these days are still kind of UWP dominant. Like, you get a lot of UWP games on the Microsoft Store and stuff. Watch on, because I'm only going to use UWP for now. But yeah, if UWP is not your source, that's fine. Anyway, thought I would just talk about UWP a little bit. Sweetness, let's go. So we're on our XAML, our markup language, and let's see now, where is it? I want to define a namespace for our canvas animator control. Let me just move it a little bit here. So I'm going to write XML, within the tag. So XML namespace, XML_NS, we'll call it that. Colon, let's see if it works. I don't know if it's gonna work. I'm getting other lines already. Background. Last one, I did it wrong, didn't I? Hold on, guys. let's see, XML, yes. Even if it's right. I don't know how I'm doing this. Sorry guys, I'm already flopping. There we go. So XML ns XML namespace colon canvas. I'll call this namespace canvas. Using Microsoft graphics canvas. Canvas UI examples down there, right? Cool. Now, I particularly like using viewboxes because viewboxes are quite responsive when you resize screens. And one thing I'm worried about with UWP is, well, not UWP, it's search, but like the scaling. So if I'm playing on a 720 monitor, say, a 1080 by 720 monitor, scaling that in a full screen manner is something compared to like other displays. So my laptop is like a certain resolution, my big TV in front of me is another resolution. How do I actively, dynamically respond to the different resolutions? Something I might need to consider sooner or later. So that's something to think about. Maybe not an engine level, but something to think about. That's more like the environment of Visual Studio as an IDE. That can be actually quite easily configured, I think. Excuse me. Okay, so what we're going to do to get ourselves started. My keyboard doesn't have a tab button. It's so annoying sometimes. Yeah, my keyboard broke and I lost the tab button. I haven't replaced it since. Anyway, let's put a blue box. Let's close the tag here. And let's put a canvas animated control. So I'm going to reference my XML namespace and reference this canvas here. I'm going to go ahead and write canvas as it shows on the right hand side of the screen on my notepad. I want to use the canvas animated control, so not canvas control. Canvas control is quite similar to the animated control, but I believe according to UWP's documentation, which I may or may not have on me, somewhere here, I think the difference is that with the animated control, you have the liberty of utilizing the drawing thread. I'll probably try, if I don't forget, I'll try and leave a link to this documentation in the description if you can't find it. Remind me in the comments if you want that. But it should go into some details here in the API reference. Excuse me, guys. Okay, sweetness. So anyway, so we want canvas animate control, and we're going to give it a name. Name canvas animated. Animated control. Let's close our tag. We do a shorthand, so we use like the /. I don't know if it's a forward or a backslash. I think it's a /. I don't know the difference. I've forgotten. This slash here, right? Could be a backslash. It looks like a / there, left to right, and a closing tag there. So it's a shorthand, right? Viewbox. What's wrong with the viewbox? Canvas animated control was not found. Okay, let's see. What have I done wrong? X name. I wonder why it's not finding it. Computer's lagging up now. Sorry guys, my computer is lagging up a little bit. I closed my the name of my canvas in the wrong place. So now we have a reference to this object called the canvas animated control, which just basically allows us to draw onto some canvas. We can draw bitmaps of the canvas. So we're already getting there. It's surprisingly simple to build a 2D game using CSharp. Like it's quite easy actually. It's quite simple. the complexity arrives when you try to go deeper into making like a longer game, more complex systems and such. But like drawing on the screen, creating a control system, and moving sprites on the screen is surprisingly easy. That's all I'm gonna say, right? Because obviously with C# you have the liberty of using like libraries and stuff like Win2D and stuff like that. Okay, so we've done that. Okay, cool. Let's do this properly. So, get rid of that. Folder structure and data access structure. I'm leaning towards Okay, so there's not one particular structure format I'm leaning towards. And I don't profess to have like fully comprehensive knowledge of any one data access structure, but I'm considering MVVM. MVVM is good for like business applications, enterprise applications, especially if you're on .NET. However, I'm building a game engine and a framework, but because I'm building on .NET, maybe I can leverage some of the mechanics of .NET. So I am leaning towards MVVM. I gotta choose something, right? And all MVVM does, this is my interpretation of MVVM, because I saw a diagram on Wikipedia and I got confused. I'm just gonna full screen this, man. So with MVVM, we can, yeah, it's best we look at the definition first. Actually, let's see. MVVM, okay. Let me talk about my interpretation of MVVM, how I may apply MVVM for Vanguard. Data is accessed. Data flow is controlled like this. Man, writing with a mouse takes ages. Where's I? Model. I'm just gonna say, oh goodness me, that's a very strange square. View model, I'm just gonna say VM. And view. Now, this is where I might be actually a bit wrong. I'm gonna maybe proofread it after this, but in our model, of course, we have our business logic. So we have like methods. Wow. Methods. Classes. Interfaces, maybe. Is it just a type of class in this sense? Interfaces, and I guess like objects and stuff. Excuse me, guys. Be like fields and methods. I said methods already. Properties, actually. Properties, right? It's a shorthand. And in the view, we have our like the domain that deals with user interface. So I don't want to use the word user interface for this. Stuff like the game scene. So the game scene visual. So I'll say visuals. Visuals. Particularly visuals. I was considering like behavioral cues to do with the game. Just kidding, guys. But I guess you could. I guess I could say like game behaviors or in-game cues. I don't know how to describe it, guys. So I'll leave it out. Let's say visuals for now, right? But I think it's a little bit deeper than that. It's like if I were to play a game, let's just say. I used to be a big Sonic fan, so I like to use Sonic Adventure. I like to use Sonic examples, like Sonic Adventure 2, say. If I'm playing Sonic Adventure 2, I'm playing the first stage. I'm on City Escape. It's not just obviously the visuals itself, it's my whole interaction with the scene between the controller that I'm holding, let's say a Dreamcast controller, and Sonic running through City Escape, the stage City Escape, right? Let's just say visuals for now. I'm gonna write Game World as a whole. Right, so now with view model, what this domain does, it kind of interfaces between view and model, as the name suggests, right? So the view will present us with some kind of cue. So I might have like a splash screen that says press start to continue. Press start, better said for me, press start to start a game. And then the view model handles the start press itself. So the view says press start. The game player sees start and press start. The press start screen, press start. Goodness me. And so the model, which has a method, say a method that governs the press start button to actually fire up the game. Then the model sends that signal to the view model, this cue, this behavior, this trigger. And the view model will then respectfully, that's not the right term. The view model will, update the view, basically said. So I know I'm using like jargon English, like I'm not really speaking very well right now. But I saw a diagram that was contradictory of this. Like it was like showing this in a different manner, but I was a little bit confused. So I looked up another article and I found this, and I like this better. I saw a different diagram. I like this one though. So you have view model in the middle between view and model, right? And we're interfacing between view and model. I could have just said that. Okay. So I want to incorporate this kind of structure because it's all about modularity. Again, we are developing these game worlds and we want to reduce as much friction as possible, right? Remember the key term that I tried to highlight was level design. Again, how is Vanguard Engine going to facilitate for level design in a very frictionless manner? I'm trying to mitigate the friction of designing levels here. That's the key of Vanguard. Okay, so we're gonna review model. So implementing MVVM goes beyond just folder structure. We're looking at data access flow. And so we have a set of mechanics in the program that kind of govern data access flow. So what I'm trying to say is methods and classes can't just be invoked everywhere. That's what I'm basically trying to say. So we want to build a simple game scene. We will reflect MVVM with folder structure though. So what I'm going to do, I'm going to create a models folder. I've actually right-clicked Vanguard, just taken a while. And there's probably like, tiers of magnitudes of optimal ways I can implement what I'm trying to do right now with folder structures and my data flow, but I'm just getting in with like an MVP, right? A minimum viable project or minimum viable product for Vanguard. I'm gonna add folder. Let's minimize my OBS. My OBS is off screen. Because I don't want this video to be too long. It's the first episode. What just happened? Really? Boy! Let's get straight into this. My Visual Studio is not agreeing with me. I'm off screen just reloading Visual Studio, guys. Man, this is really... Boy. It is what it is. I take it I ran out of memory. It's a really old laptop I'm on, but it is what it is, man. If this takes a bit too long, guys, I will limit the stream to just the theory, and then we'll get into the nuts and bolts in the next stream. I really wanted to just like get started with the coding, but I'm having some technical issues here. Let's see. Is there any date? I didn't really do much. Do I want to recover it? Does it make a difference? Here's a backup. 2109. Most recent backup. 2109. I don't want to go back because it's like almost 10 to 11. So this is a very early backup. It's better if I don't recover. I think I've been just hitting Control S, like instinctively, so I should be okay. I didn't even write anything really. I just like loaded the markup a little bit. If this takes more than like 2 minutes, guys, I will just run through the theory. It's 51 past 10 in the evening in the UK. If this takes more than 2 minutes to kind of like get up and running, I will just go through the theory for this episode, guys. I don't want to waste your time. Right, okay guys. Because of what's going on here, I'm gonna just go through the theory for episode 1. So it's not gonna be a long stream. I apologize. And then for the next entry, I'll do my best to prepare things beforehand, i.e. restart my computer, because that always makes things quick and obviously releases a lot of resources. I've got too much stuff running right now, I suppose. So I spoke about MVVM a little bit. I don't know if there's much more to say right now other than just like get started. Let's see now. It's annoying that I can't just get into the code, man. What do you know about all this stuff? How long has it been? Been about 40 minutes. Unless there's anything else I've missed out, guys, I will wrap up soon. I have gone through some of the theory. It just sucks, man, that my computer's doing it, but it's like I have to restart my laptop to make it go fast, and I'm not going to just do that because obviously it'll cut the stream and stuff. So this would be a theory-based episode. I don't want to just talk though, so I think I'm going to wrap things up. Oh, I'm really annoyed at that, but it is what it is. Okay, some principles I want to implement, you know, I have like solid here. Man, it doesn't make sense if I don't actually show it, but we'll go through these. I promise, guys, there will be, you know, as long as the stream continues, we will go through some decent code and some design principles. It will be okay. Hopefully by tomorrow UK time. I'm trying to stream this quite regularly. I'm sorry about this, guys. I promise next stream there'll be some like decent coding and stuff. I'll try and get things prepared for that. Okay. But for now, let's leave it here. We went through the theory, went through my idea, the drafting phase. I'll redo the title of this stream so it's not clickbait. And yeah, we'll get to coding in the next one. Spent 40 minutes only for Visual Studio to crash, and I anticipate perhaps that Visual Studio will continue to crash or take too long. So I'm gonna cut it here. Thanks, guys. We will get into the nuts and bolts tomorrow UK time. Maybe early in the day, maybe around lunchtime. I'll see what's quite appropriate. Right now it's kind of late, so it's not really appropriate for everybody. But I hope you have a good day. So thanks for tuning in, and I bid you all a great day. I'm going to tune out for now. Bye. Oh, I've got some comments. Hey guys, I see your comments. I'm going to address the comments before I go. Can Win2D render images, or is it just shapes? So with Win2D, you can draw, basically you can stream in textures that can function as sprites, right? So it's not just shapes. You can assign, let's say you have a Sonic game, you're building a Sonic fan game, and you have a sprite of Sonic, right? You can import that sprite via Win2D and other graphics to build your scenes. So answer that question. Man, thanks for tuning in, guys. I'm so sorry I had to cut the stream short. I promise tomorrow when I stream, we'll get into the nuts and bolts, the coding, okay? Alright, take care, guys. Thanks a lot. Bye.